A vector is defined by vector modulus or magnitude or length, and we write it as in absolute value a vector. So, and direction. Vector has a magnitude and direction. For example, if you draw this line here, a vector connecting between the point A to point B, that vector here has a direction and has a magnitude. Now, vector can be written as either AB, and we put that sign up, the arrow at the top of AB, or some people say as A and the line on the top of that, instead of to differentiate it from a letter. So we put A on the line at the top, A dash, A bar or dash. So this is a vector. Some textbook write a vector as a bold character. A bold character. So they put a bold character. You see a lot in some textbook. They write a vector as a bold character to differentiate it from a letter A. So in many ways. Now in this course we're gonna focus on the second way to write a vector, where A dash or A bar is called a vector A, which has a magnitude AB and has a direction. Okay? Where we find vectors in, for example, the force, consider as a vector of force. Velocity as a vector of velocity. Weight of an object as a vector. You find it everywhere. For example, if you have a wall or the ceiling and you have an object here and you place the object by ties. Now if you need to draw the free body diagram, I will take the object, I'm gonna put on that object, if you cut the ties here or strings here, you will generate a load there and a load which is considered as a vectors T1 and T2, which are the forces in the string. So assume this is ceiling and you have an object and it's connected to ceiling through a string or rods, okay? So the string, the tensile in that string is T1 and T2, and we wrote it as vectors. And the weight of that object, considered as W, goes down. So this is a vector, which is direction goes down and the value is W. If you have a beam supported here and supported here, the reaction under the loaded here, this is a loading, a point force, or you could load it by, for example, if you have a snow on a roof, you draw the snow as a distributed load, which is vector of loads. Then the reaction, drawn out a vector of reactions, has a direction up. So vector is everywhere actually in engineering. You could have felt vectors of forces, velocities, accelerations. Now, Cartesian forms of vectors. The Cartesian form of vector. So assume a system of x, y coordinates system, okay? The unit vector in the x direction, in the x axis, is, now the unit vector, we call it I vector. Where we place it, okay. Just draw it here. That's the coordinate system X and Y. I will assume there is a unit vector. When we said unit vector, mean the magnitude is 1. The length of that unit vector is 1. So unit vector I, it's in the X direction. Unit vector in Y axis, which is called J. So unit vector in Y axis, J. So you have axis Y, you have a unit vector J in the Y axis. So unit vector is a vector that its length equals to unity. So which means that I vector the modulus magnitude length of I equal to modulus or magnitude or the length of J equals to 1. Now assume vector R. You have a vector R shown below. So you have a vector R, it is shown here. The Cartesian form of the vector R is, now if you take the projection of R over x-axis, you know what the projection is? Huh? So if you project R on x-axis, it gives you a length Rx. If you project, or you make the projection of R in y-axis, it gives you a length Ry. Okay? So what you can say that R is written as Rxi plus Ryj. Okay? Fine? Where Rx and Ry are the projection of R in X and Y respectively. In X and Y. Okay? Now, some textbooks write R as a vector R, Rx I plus Rj Y J. Some textbooks write it in a column notation, in a column vector notation. They put Rx and Ry. You will find it in a lot of textbooks. So this is column vector notation. Column vector notation. Okay?